Why is Faraday's law essential for electrical transformers? Have you ever wondered how electrical transformers work? The secret lies in a fascinating principle known as Faraday's law. This law is vital for understanding how transformers transfer electrical energy between circuits. So, let's break it down in simple terms. Faraday's law explains that when a magnetic field changes around a coil of wire, it creates an electromotive force or voltage. This is the core idea behind how transformers operate. In a transformer, there are two coils, the primary coil and the secondary coil. The primary coil connects to the input voltage source, while the secondary coil connects to the output load. When alternating current flows through the primary coil, it generates a changing magnetic field. This changing magnetic field passes through the transformer's core and induces a voltage in the secondary coil. The amount of voltage created in the secondary coil depends on two things: the rate at which the magnetic field changes and the number of turns in the coil. The relationship between the voltages in the primary and secondary coils is captured in a simple equation. The voltage in the primary coil divided by the voltage in the secondary coil equals the number of turns in the primary coil divided by the number of turns in the secondary coil. This means that, by adjusting the number of turns in each coil, a transformer can either increase or decrease voltage levels. This ability to change voltage is essential for efficient power distribution. Now let's talk about why this is so important. Without Faraday's law, transformers wouldn't be able to function. The principle of mutual induction, which allows the energy transfer between the coils, relies entirely on this law. This means that the magnetic coupling between the coils is crucial for the transformer to work effectively. In practical terms, this principle allows electrical power to be transmitted over long distances. By stepping up voltages, transformers reduce energy losses during transmission. When the power reaches homes and businesses, transformers step down the voltage to safer levels for everyday use. Additionally, Faraday's law is not just important for transformers. It also plays a role in the design of various electrical devices like inductors, electric motors, and generators. Understanding this law gives engineers the tools they need to create efficient electrical systems. In essence, Faraday's law is the backbone of how electrical transformers operate. It explains the process of electromagnetic induction, which is key to transforming voltage through changing magnetic fields. This principle is what makes modern electrical engineering possible, allowing us to enjoy the conveniences of electricity in our daily lives.